Okay, now, guys, by now most of you are pros at solving equations, multi-step equations. So we're going to talk about how to determine whether you have one solution, infinitely many solutions, or no solution. So if we look at some examples here, let's say that you had the problem 3x minus 6 equals 2x plus 8. All right, so if I go to work this out, so I need to subtract 2x here to cancel it on the side that it's on, and that's going to be x, okay? So if my variables go over here, my constants have to go over here, and I got to cancel it on the side that it's on, and so that's going to be 14. So x is going to be 14. That is my answer. I know that it is a solution because this is one of the questions, is because if I put 14 back into both sides of the equation, then I'm going to see if it makes a true statement. So 3 times 14 is 42 minus 6. 2 times 14 is 28 plus 8. So 42 minus 6 is 36, and 28 plus 8 is also 36. So we know that 14 is the correct solution. Now, so let's say that we had an equation that looked maybe something similar to this. Okay. So, as we already know and have studied, we're going to distribute there and say that that is 6x plus 8. And then we're going to multiply this together and say, okay, this is 14x minus 8x. So I'm going to put these together. This is going to be 6x plus 8. And then over here, this is going to be 6x. Now, if it helps you, because these are the same, you could write plus 0 to help you kind of analyze this. Don't need to, but if it helps you, that's fine. So I'm going to use the same thing that I used over there. I'm going to cancel this on the side that it's on. And notice here that I get 0. And then I'm going to subtract 8 over here. And this gets me negative 8. So we're going to look at this statement right here and say that's not true. 0 does not equal negative 8. So this one is no solution. And what that means is that there's no answer in here that I can put in for x and make both of the sides equal. I can't keep the equation balanced. So one way to tell this prior to working these two steps is that notice that you had the same coefficients on each side, but these were different. Well, that's essentially saying if I start out with $6 and I add 8 to that, and I start out with $6 over here and add nothing, is there any way that those could be the same? And the answer is no. So that's why that one ends up being no solution. So one of the telltale signs of this is if you end up with the same coefficients and different constant values. So then another example is, let's say that you had maybe the same type of a question over here. Okay. So again, I'm going to distribute like you know to do. So 6x plus 8. And then over here, I can combine my like terms, and I'm going to get 6x plus 8. So again, what happens? If I work this all the way out, I'm going to get this to be 0. Now, a lot of people write 0x. 6x minus 6x is just 0. There's nothing there. So then I'm going to say minus 8 over here. So 8 minus 8 is 0. Well, does 0 equal 0? Yeah. So what that means is this one means that it's true or infinite, all real numbers, for any value that I put in here. So this says if I give you $6 and I add 8, and I give me $6 and I add 8, if I multiply what I gave you originally by 2, that means I would have to multiply what I gave me originally by 2, and we would still be equal. Or if I multiplied what I gave you originally by 3, that means I would have to multiply what I gave me originally by 3, and we would still be equal. We could put 2 in there, 3 in there, we would be equal. So there was a clue right here that told us it was going to be infinite. Because both of these sides were already balanced, whatever number that I put in there, because they're both x's, I have to put the same number in on the other side. So this tells me that anything I plug in or substitute in here is going to be keep this equal. So this would be all real numbers. So let's recap. So if I have something like this, because these are not the same, I'm going to get an answer. It may be a fractional or decimal answer, but it's going to be an answer, a solution, a number that will go in there and make them the same. If I were to get something like this, because this is the same, I'm taking the same amount and I'm adding 3 from one side and subtracting 6 from the other. There's not a way that this can be equal. So this one is no solution. So now, the way that it can be the same is if they're exactly the same on the both sides. I don't have to go into solving for x because I can tell that no matter what I place in here, these are always going to be the same. Now, obviously, most of you, if you see this, you'd be like, oh, those would be the same. But they can hide these very discreetly. Like this side could look like this, and this side could look like this. And when I got done, this would be what it looked like. So watch out for that. If you get to this part and they're the same, then you're good. Okay? The other question they like to ask you is they like to give you a question like this. Let me see. It's hard to make these up. Okay. So then and they would ask you what value of b would make this equation have infinite solutions. So I'm going to distribute and see what this gets me here. So this would be negative 10x plus 4 equals bx. I can't do anything with that. And negative 8 or plus 8 minus 4 would be plus 4. So infinite solutions, what do we know? We know they have to be exactly the same. So if that happens, then I need to know what this needs to be. Well, it needs to be, b needs to be negative 10. And so if that b was negative 10, then it would say negative 10x plus 4 equals negative 10x plus 4. And so these would be infinite solutions, or all real numbers. Let's see if we can come up with another one here. And so it might ask you, what would b need to be to make this no solution? All right, so I'm going to work this out the same. And this is going to be 5x minus 10 plus x equals 2bx. Now, don't let that confuse you. I'll explain in just a minute. You're saying 2 times b times x. Well, the question is, what would b have to be? So let's continue over here. 5x and 1x makes 6x minus 10. And this is 2bx minus 6. Well, if I need to make this no solution, what is it that I need? I need the same x's, same coefficients, but different constants. My stylus is not wanting to work today. So let me try that again a little neater so that if you're taking notes you can read this here. So same coefficients and different constants. Okay, that's a little better. So which criteria have I already met? Do I have different constants? Yes, I do. So here I have 6. So is there something that I have 6x, so is there something that I can multiply by 2 to get 6? 3. So B would be 3. Now that would be 6, 2 times 3 would be 6x minus 6 on this side, and this would be 6x minus 10. Well, this would be no solution because I have the same coefficients, but I have different constants. So B is 3 would make that true. All right, I hope this helps. Thanks, guys.